how do you get the materials to the top floor? It's nearly half a kilometre straight up.
Taipei 101 has an 18th century preacher and his steam pump to thank for the solution. With a building as big as Taipei 101, every structural challenge is supersized, especially when working with the construction world's favourite material, concrete. Every floor on Taipei 101, including the 101st, is concrete. To pump concrete that high requires a super pump that has its origins in the 17th century. Rewind 300 years. The English mining industry is in trouble. The deep mines are flooding, and the man and horse-powered pumps available can't drain water fast enough. The mines are going under. Inside this modest building sits the machine that saved the day and kicked off the Industrial Revolution. It is the result of a stroke of genius from an inventive preacher and ironmonger, Thomas Newcomen.
This is Newcomen's Nodding Donkey, the first piston-powered pump.
And the first really practical engine for pumping water. Newcomen's idea was to harness the power of the pressure difference created by a vacuum. He used it to move a piston.
It works on the vacuum created by the steam when it's condensed. It works on the principle that steam occupies, say, this much space, but when you cool it and turn it back to water, it occupies a fraction of that space. So this, under here is the water, the tank, and under that is the heat. Heating it up in the boiler as steam up into that big cylinder, which is the piston. That pipe goes in to the bottom of the piston, sends the cold water in, that condenses the steam, and suddenly that huge volume of steam is reduced to just a tiny volume of water. And then atmospheric pressure outside on top of the piston is greater than the pressure inside, and it's got no choice. The piston has to come down, drawing the beam that way to do its work. Then it's counterbalanced, so it just pulls the piston back up to the top. More steam in, condenses it again, draws it back down. They were very clever.
Throughout the rest of the 18th century, Newcomen's invention drains countless mines, helping fuel the Industrial Revolution. 24 years after his death in 1753, the first Newcomen-style pump crosses the Atlantic to begin draining a copper mine in New Jersey. Fast forward 2.5 centuries to the offspring of Newcomen's engine. These powerful piston pumps use a vacuum and mega pressures to deliver concrete skyward and into the record books.
In August 2003, a world record was broken, just up there. It was the highest anyone had ever pumped concrete on a building. It had to be raised 101 floors from down there.
A pipe filled with concrete this high weighs well over 13 tons, and pumping it takes technology Newcomen could only dream about. Pumping concrete is big business, and as buildings get higher, the technology to power it to the top gets more sophisticated.
This is the business end of a pipe network that extended over 440 metres that way.
A chain of interconnected pipes stretch to reach the high floors. On Taipei 101, the pump sits near the base of the building, and the rooftop lies 4.5 football fields above. The concrete is kept flowing by a super pump. Meet the 12-cylinder, 419 kilowatt Deutz diesel engine.
This is the heart of the operation. Literally, it's the pump that keeps the construction alive. The moving parts in here made it possible to pump the concrete even to the highest floors.
A column of concrete must be kept flowing, or the mix will separate, or even worse, set. To keep a constant flow, the pump operates 2 pistons. One sucks while the other blows. A simple vacuum, like Newcomen's, pulls the liquid concrete in. Then the huge diesel engine generates hydraulic pressure to push it out. It's Newcomen's ideas, just hundreds of times more pressure for a much weightier task. I want to see what kind of pressures the Taipei 101 pumping world record used. So pump specialist Phil Suri devises a pressure demo that will blast my weight in concrete.
It's difficult to get your head around the kind of power and pressure that modern pumps can generate using those old techniques. So rather than just talk numbers about it all, we've come up with a rather clever way of demonstrating very graphically what that power can do. We're going to use pressure to move some concrete, but we're going to do it in a rather different way.
Using a concrete missile as heavy as me, Phil and his team are going to demonstrate what 100 bar of pressure can do. 1 bar, named after the Greek word for weight, is about 1 kilogram per square centimetre, or roughly the atmospheric pressure all around us. I pump my car tyres to 3 times that, 3 bar, and that seems like a lot.
Is that the firing cable?
Huh? That's the cable to fire it, that's a trigger.
Right. That's
what I said, you trip over it.
Cool. Sorry.
I'm sorry.
But this will give me an idea of what?
Of what 100 bar of force is capable of doing. Taipei Tower, the pump that we used there was capable of 200 bar pumping pressure. This is only capable of 100 bar.
So your pumps,
roughly half,
your pumps can generate twice the pressure of this.
Exactly. Yep.
And you're just telling me that because you're proud of your pump. That's what that is.
Yes, I am.
Yes,
yes, I am.
This is a first for me, obviously. I've never seen a chunk of concrete my weight fired from a cannon. Phil is keen to see how far his concrete missile will go. The safety team are keen to make sure no one is on the receiving end.
Fire.
Wow. So that's half the pressure on a lump of concrete the same weight as me.
Yep.
That's...
You're what, about 140 pounds?
Yeah, 64 kilos.
Okay, 10 stone, okay.
Have we got to go and get that thing
Yeah,
now?
let's do it.
Crikey.
The launcher blasts my concrete twin well over 90 metres. The top of Taipei 101 is 4 times that distance, straight up.
12, 13.
And the record-breaking concrete column was 220 times heavier than me. I now understand the amazing pressures Phil's pumps achieve, sending concrete to the 101st floor of the Taipei Tower.
It's buried itself.
It's buried itself, yeah. It's quite impressive, look at it. 106 paces.
The mechanical pump has come a long way from Newcomen's wheezing steam engine. That's how they got concrete to the top.